Hi everyone, so today I'm going to talk about rivers and apply it maybe a bit to fish keeping. Freshwater only covers around 2.5% of water on Earth, and 70% of that is locked away and frozen. That only leaves around 1.75% of water on Earth that is liquid, and a lot is going to be trapped in groundwater, so maybe not so accessible for fish. So around 0.3% of fresh water is in lakes, rivers and other wetlands that fish can use, basically. Yet 50% of all fishes inhabit fresh water. It's a sort of around 50, it's not exactly, but we're still discovering more and more freshwater fishes, so that might increase the number even more. Many of these fishes we buy in the hobby originate from rivers and their extensive drainage basins or wetlands may be related to rivers. The Rift Valley lakes, I believe, many of them are connected by different rivers, hence why they are maybe a little bit more inhabitable than sort of closed lakes. But I'll talk about lakes probably another week. By understanding rivers and their hydrology, their geography, we can understand our fish's biology and care even more. Rivers are extremely diverse across the world, while also containing a diversity of different habitats even within one river, one stretch of the river, just small portion of the river. They're extremely diverse, and if you look at the rivers around you, you might have different ecosystems or different types of rivers. In South America we know about the Blackwater rivers, Clearwater. You've also got different stages of the rivers. In the UK you've got chalk streams, which are extremely threatened and important, and this sort of diversity leads to different species that can and are adapted to a wide diversity of different freshwater habitats. So this is sort of a classic river, but not all rivers work in the same sort of way, so bear that in mind. So at the top here we've got the headwaters, middle would be midwaters, and then we've got the sort of bottom waters, low waters. Now be here, sort of, but you got a bit of variation. It is, so basically, this is a very simple graph if we look at it. So generally you'd have multiple tributaries running into this main channel, and that will increase the water volume within the main channel rather than suddenly water existing. As a river goes downstream, therefore it does get wider, it does get deeper. That sort of output is increasing, but the velocity is a lot higher. Generally, rivers start the headwaters tend to be are a higher altitude. They're going to be at a higher altitude, so that's got a higher water velocity because it's got to go down with gravity, and therefore it's going to be a lot more straight. It's not getting too much resistance in sort of going straight down, rather than as it starts to slow down and altitude decreases. So as you get lower down, it's getting closer to gravity, there's more resistance and it's starting to bend. And this is meanders, and they will change over time as you get difference in outputs depending on seasons, and also maybe even meeting other geological features or aspects change. And that's how you get oxbow lakes if that bit gets cut off. Also meanders, you've got the higher flow round here and a sort of a lower flow around the outer bend. You've also got different aspects of where flow will differ or water velocity will differ between sort of the main in the channel, and also like boulders and stuff will influence it. So this is where you're going to get the largest amount of sort of very large rocks, potentially logs, but they're most likely going to go downstream, so you're not going to get much sort of deposition up here. This is going to be your largest boulders. There's going to be no sand. Maybe the influence of the boulders will allow for sand to be deposited in some regions, but that's going to happen more and more as you go downstream, so you're going to get larger and larger bits of sediment till you get down here, where especially on these outer bends you'll get sand, silts, and further down you'll get even more, like stuff like when you're going to start getting leaf litter. And it does depend on other aspects of the geology of the river. And obviously I'm not a geologist, so I can't state too much, but you see that trend also in turbidity. This is when also you got less water, because you got the other channels, I assume is why I can think that the turbidity is going to be lower. It also suggests that a lot of this water is coming from likely groundwater, or maybe up at higher altitudes where rain and precipitation, frozen water melts and goes downstream. So this is going to be a lot more influenced by the geology, whereas this is maybe more influenced by terrestrial environment. So the turbidity will start to increase as it's also starting to pick up more and more sediment. So that will increase turbidity. If we compare turbidity quickly with the different plant biomass, so this is submerged plants, that's the plants under the water. They're not going to want to grow where there's high turbidity in general, so you're not going to see because they need to photosynthesize, so they're not going to get that much light where there's a high turbidity. Turbidity being sort of the clarity of the water. You won't see many, for example, black water compared to sort of clear water rivers. So that's a major reason why you get that dip, sort of the total opposites. Here, especially at these headwaters, because there's not much sediment, there's not much really for plants to cling onto and grow onto, so you're going to get a lot more biofilms, stuff that really can cling on, and it's not going to be too large because it's just going to get blown downstream if it gets too big. And that's the major reason I guess you're not going to see plants so much. Also, there's a lot less nutrients here than down here, especially sort of more organic nutrients, opposed to this is sort of the micronutrients you're going to get from the bedrocks themselves. So you're going to see a massive change in water chemistry as you go downstream. And then because here where there's that high turbidity, you're going to emergent plants are going to start outcompeting. They're your sort of riparian vegetation ones that can grow out of the water. They're not going to be bothered so much about that higher turbidity because they can get out of the water as quick as possible. They also don't want that higher flow because they're not got anywhere to root. A lot of them are going to want to be in those meanders where it's a sort of a slower flow, and there's a lot more nutrients being picked up and deposited around them. And I think also this emergent plant biomass, also submerged to a degree, does influence the the geography maybe of the actual river, as these are going to start trapping nutrients between the plants, between the roots, so you're going to get a change where they're present as well. So that's the influence of maybe biotics. Phytoplankton biomass, generally as nutrients increases, you're going to get more phytoplankton. Obviously they do rely on light as well, so they're not going to grow too well where it's too dark. So it depends also on their definitions of plant versus phytoplankton. So plants, sometimes people throw algae under plants, so whether this means, because there aren't that many truly aquatic plants, it's a really difficult environment for freshwater. Like submerged freshwater plants, there's plenty of riparian ones, loads of them. But long term underwater is really challenging, especially up here where you've got very little stuff, substrate to grow in, like you've got gravels and stuff. So this could refer more to algae, whereas this could refer maybe more to ones that are in the water column themselves. But it's not entirely, I don't think, producer communities, I should have read it maybe a bit more closely. But you can see the difference, there's a big influence of this area which is picking up large sediment, moving it down, and this area that's depositing it and leading to the estuary where you just get loads, and that sort of channel increasing in size. You can actually see here where this meander looks like as it sort of erodes into this area, it's going to start breaking in. You're going to get an oxbow lake form. And rivers are very dynamic places, they change all the time. The most famous, I'd say, being the Nile, where it's cut off regions and then people have had to move, cities have had to move to actually get enough food, because everything really relies on fresh water. So you might be thinking that maybe the lower nutrients or less depositation of that nutrients and sediment, and maybe even the lower plant diversity at that higher velocity water, especially upstream and headstreams, would lead to a lower biodiversity and lower species diversity. But in fact, in invertebrates and in fishes, there has actually been studies showing that there is a higher species diversity in the fact that there's more diversification and generally more sort of divergence into a wider variety of morphologies where there's higher flow. And this kind of makes sense because the higher flow does create quite a few different sort of ecosystems within it, and it makes it maybe a little bit more competitive of an environment. But there's plenty of studies, and you can see the papers that I've shown now, but there are plenty more to read. You can see something similar to Headwater. It's obviously not the sort of the highest reaches of a river. There is a bit of meandering and a bit of deposition where you can see it here. But there is many large boulders. There's not going to be much sediment building up. Maybe a little bit, as I said, sort of maybe towards the sides, which would allow for a little bit of plant growth. But a lot of it, and maybe even below some larger boulders, a lot of it's going to be pushed downstream. So what environment is this? Is quite highly oxygenated. Obviously there's not much sort of traditional plant matter, but there'll be maybe more algae, biofilms, so that's stuff that can really cling to the surface, but it's not going to be substantial. It's only going to be sort of a very thin layer. There's nothing that really needs to be able to dig in a substrate, so in a silt, in the sand, through leaf litter, because there's not going to be anything there, so you're not really going to see these or so much see anything like Geophagus, maybe Corydorus or anything like that. You're going to see maybe a lot more Lorcarids, hill stream loaches, obviously not in the same habitat, anything that can withstand that higher flow. And you will see some shoaling fish, but they've got to be able to manage that movement of water, and a lot of the things will be feeding on the different organisms that'll be living there. You're going to get different invertebrate larvae, so sort of insect larvae that can cling onto something, and also potentially quite a few annelids, bryozoa. I'm not sure, Actually, sponges are a possibility in the Rio Xingu. There's plenty of different freshwater sponges. So you can have whole different types of life in these headwaters, but they're not something that you're going to get any plant matter, or really I would say much of this, the traditional, what people see as a natural aquarium, is very different from these highly diverse head streams or headwaters of a river. And of course, further down in a river, you might get more water. So it really depends on that river, the individual river. Look at the Rio Xingu, for example. There's regions of really, really high flow, and I wouldn't say they're entirely at the headwaters. But this is maybe something to look at and think about replicating, because obviously these fish will be feeding on the algae, the biofilms, what we call ulfrich. They're not going to be feeding on plant matter because there isn't any. So this is thousands of years likely of thousands of years of adaptations to, well, not really having plant matter particularly. So their gut is not going to be evolved for it, and also they're going to be highly evolved for highly oxygenated water. They're not going to be able to adapt so easily to sort of lower oxygen levels, but then maybe also flow and higher temperatures maybe, or lower temperatures. So there's a whole sort of geology and geography to different rivers that really are worth thinking about. You can see here that there's so much enrichment, and you can provide this in captivity with a powerhead. The higher power the better, depending on the species. Not all orcas are going to be found in water like this, but likely having boulders, breaks in flow, regions of higher flow, regions of turbulent flow, regions of laminar flow, anything like that. And then also allowing for these microbial systems to grow, and a way of actually promoting them. Rapashi is a good one, and also other sort of, well, Rapashi as in like a replicant of the diets that might, if they're feeding on those services. You're also going to get other things. A lot of nutrients is going to come in from terrestrial sources, and that's where a lot of nutrients does come in on fresh waters. Also stuff that specialises in those insect larvae. In the UK, I think particularly of birds that do. But you're going to get fishes that will specialise in getting into the cracks and crevices here. Rather than having barbels and sifting through a substrate, they're going to be getting in those crevices to get at the invertebrates. So maybe stuff with a more pointed head. And maybe that makes you think about Pseudacanthicus, Leprocanthicus, and also Scopidensis, true carnivores and hyperstominated echoes. They've got very pointed heads, so they're just trying to get in there maybe at the different things, at the even the mollusks. So maybe it's not all about what we traditionally think about fishes. And this is an exceptionally well planted ecosystem. So this planted, well, freshwater river, it seems. If you look at the flow, it's definitely directional. But it's sort of, this is going to be your mid-waters. You can see there's a lot more sediment building up. So places for the plants to root. As that sediment settles more, it's allowing maybe for more light to get in and more photosynthetic or more plants to grow. These are you can see the difference of true aquatic or submerged plants compared to sort of a lot of the ones we keep. These are very sort of not very strong structures. They're not very rigid, so you take them out of the water and they just flop. Whereas a lot of plants we keep underwater, probably why they can be a little bit more of a challenge. They're not entirely adapted for this life where they don't need to be rigid. So a lot of more terrestrial, emergent plants, riparian, they're quite strong. You take them out of the water and they stand up because of those cell walls and will be intercellular structures. And yeah, you can see here a lot of sediment, a lot of sands. Maybe there's also the sort of how the this riverbed is laid out is allowing for pockets of sedimentation. You can also imagine, as I said I think earlier, these plants are allowing for more sedimentation. They're creating their own ecosystem. Further down there's more pebbles, so maybe there's the sort of centre of the channel is further down that sort of way, if you really look here. So it really depends on where you are in this river. It's very wide as well. You can see the flow is a lot less strong, and there's going to be a whole different sort of chemistry to this area. It's likely to have a sort of, it's very difficult to almost, because you've got upstream, you've got a higher sort of, it might be influenced a lot by the rainwaters, sort of waters from the ice, glacial waters maybe, depends where you are, springs, so the geology. But it doesn't mean it necessarily be harder. I'll say when it comes to other aspects of water parameters, this is going to be warmer, because it's sort of in direct light especially, and it's not sort of charging downstream before it's time to warm up in a way, if you get what I mean. And I'm probably going on a little bit of a tangent, but you can see here how well planted it is, and this is exceptional. A lot of freshwater is nothing like this, especially if you go for black water, because there's next to no light. But yeah, this is sort of maybe some mid-waters. You do get it even in the UK. Our chalk streams are exceptionally clear, and you do get plants growing. Maybe also this will influence other organisms and the diversity of fishes you get. Does this mean there's a diversity of ecosystems and habitats? Compared to the faster flow, is very difficult to sort of suggest. Here we can see maybe another example of something maybe mid or more lower class down the river. It's on the edge of a meander, so you can see there's maybe a lot of depositation of nutrients, or well, silts, substrates, stuff like that. Maybe that's what's enhancing the algae growth here. On the other side, this looks more like gravelly. There's stuff that can't be picked up by this sort of lower energy water, so it's just left there. That also probably affects that the algae is getting deposited here, but it's just being shoved downstream that side, on the inside of the meander. You can see the lower flow, the boulders, these aren't going to be lifted. These might be reminiscent of another time, another sort of flow in the water. Another aspect of this sort of water, maybe compared to the head streams, is that when we think of the aquarium hobby, and obviously sort of ornamental fishes, we also got to think about where people are fishing. So somewhere like this, it's going to be a lot more easier to get fish from. So headwaters, maybe with the more specialised fish, especially some of the hill stream catfishes, the fishes we see at the real, like extreme of adapted to high velocity waters, we're not going to see so much, because there is that ease of catching, and there's many waters that are a lot more difficult to catch fishes in. So you're going to see maybe a bit more mid-course or upper mid-course style waters. This, as I said, this doesn't always translate. It depends on the river itself, to its actual and its actual morphology really. Maybe it goes down a gradual altitude and then it suddenly increases, or maybe loads more tributaries join it later. That could, I assume, affect it. So there's so many different aspects to rivers and their morphology that might affect how we, what fish we get from them and what influences that. Down here, as you get towards the mid-course, you're going to get also wood depositing a lot more commonly. That wood's going to create its own ecosystems. Wood in water is extremely important for breeding fishes. Obviously we know there's stuff like wood cats that and other catfishes that enjoy living in sort of using the crevices as hiding places. And obviously it is, there is the panax, panacus, and stuff that utilise wood to obtain their diet almost. Here we have a habitat that a lot of people may recognise as what would associate with South American biotopes. Of course, this isn't entirely the only biotope sort of habitat you get in South America. It's very difficult to say this is Blackwater, because while there's a high turbidity, you can see a lot of stuff moving around. As I said, there's higher flow in other regions that won't allow for this leaflet or sediment to settle, or even just be like floating around that easy. This is going to be on the lower course, or maybe a stream that's got a lower flow rate, a lower sort of gradient. That's the word I should have been using for like the whole time. And therefore you can see that there is a diversity of organisms, but there's going to be a difference of diversity. So these ones are probably going to be using the difference in how it differs. As I said, you're going to get things rooting through this substrate because there's stuff to root through, there's loads of trapped sediment, and that's going to encourage a whole different microbial ecosystem. And the higher turbidity looks like it's not supporting as much or letting as much light filter through. You're getting a bit of algae, but maybe that's also outcompeting the plants. Maybe the nutrients is trapped differently. Maybe it's more in the substrate, and therefore any plants get outcompeted by microbial films, heterotrophs, opposed to otherwise. So there's so many different things you can assume. Maybe there might not be as much nutrients in the water column, therefore, as I said, it's in the substrate. I'm not a botanist, so but you can see there is loads of life like this. Whatever, that's like microbial films of loads of different kinds. You've got algae. Obviously, there's so much we can't see, and this is created just promoting. There's tetras. You've got apistogramma. I think that's about it. Tetras. I'm just going to say characins, crassiforms is easier because, and there's so much you can see. In a habitat like this, you might get maybe more like geophagus, discus, pterophyllum, which is your angelfishes. Anything that's happier to deal with this lower flow. Maybe difference in oxygen levels, we could assume. But also different feeding resources. So you're going to get a lot more maybe traditional generalist detritivores here. They're going to be feeding in this, looking for microbes and stuff they can digest. And also just a whole different group of feeders rather than those that are scraping off, because that's where the food is. You're going to get a lot more ones that are going rummaging in. Maybe less, potentially could get quite a few filter feeds, especially here. You wouldn't want anything that's going to be more stationary, because also that might be an effect on the plants. A lot of sediment's going to be building up, so plants that can't grow as quickly are going to get sort of trapped underneath. Hence where you're getting a lot here where there isn't going to be stuff building on top of it. So that's where you're probably going to find your rotifers, your algae, microbial films, stuff like that. Maybe in future you'll maybe look at your fish and think about where they come from and where exactly in a river they come from. Just because they come from a river exactly, it doesn't mean that they inhabit the same habitat. Like we have discus in the Rio Xingu, they inhabit maybe slower flow regions than the Loricarid plecos that we're used to, and the Leperinus. What else? Other fishes that inhabit the Rio Xingu, and they inhabit different regions, and this just creates so much diversity, and it makes it so much more interesting when you can look at where these fishes come from and the diversity of different habitats, and you'll learn a bit more about the fishes and maybe solve some, well, what we thought might or were challenging, maybe why they weren't living so long, maybe why they weren't feeding, maybe why they weren't breeding, if we maybe look at their habitats. And I'll go over other topics in other weeks related to maybe different fish biology and fish habitats, and I also go over lakes, which are a whole topic in their own. Anyway, thank you for watching.